And we're back. I want to go through two more examples with you about how to factor a quadratic expression that is missing the x term. So first, we're going to factor x squared minus 49. Okay, so we start with our area model. We're going to place our first term and our last term. We're going to take a look at the product of our diagonal, which is a negative 49x squared. And we also want to think about our sum, which in this case is 0 because there is no x term. Remember, this can be rewritten as x squared plus 0x minus 49. So when I go to make my diamond, I know that my product is a negative 49x squared and my sum is 0x. The two numbers that will help me multiply to a negative 49 and add to 0 are negative 7x and positive 7x. So I'll fill those into my generic rectangle and I will work on finding the dimensions. I need an x and an x to multiply to give me x squared. I'll need a negative 7 over here to help me find my negative 7x. I'll need a positive 7 here to multiply to negative 49, and that will also help me multiply to positive 7x in the upper right-hand corner. That means that x squared minus 49 factors into x minus 7 times x plus 7. I want to go through another example with you. What if we are trying to factor the quadratic expression x squared plus 4? What would that look like? Again, I'll make my area model, place my first term and my last term. I'll take a look at the product of my diagonals, which will be positive 4x squared. And of course, my sum is going to be 0 because there is no x term. I have 0 x's. When I use that to work on my diamond problem with a product of 4x squared and a sum of 0x, if I take a look at all the combinations, that will bring me to 4x, a positive 4x by multiplication. It's 1 and 4, negative 1 and negative 4, positive 2 and positive 2, or negative 2 and negative 2. Unfortunately, none of those combinations will also add to give me 0. So this quadratic expression is not factorable.